You almost had it.
The like tropical. Yeah.
Grapefruit and kiwi.
How is that gross?
Well,
I mean, I'll eat it, but how long is it
Go
been
ahead.
bad?
Since this morning. That's just not good.
Okay.
It's not like it's bad.
Find the equation for the lines that are tangent and normal to the graph of y equals secant of x at x equals pi over 4. So y equals secant of x at x equals pi over 4.
Knock yourself out, Nathan. There you go.
Can't be that bad, right?
I'm pretty sure they're like Brooke's favorite because I remember getting those for somebody last year for an end of season like snack, and I'm pretty sure it was one that I actually bought, which I bought this one last year, so I think that was it. I like the end of season goodie bag thingy. Nathan looks like he's not sure about that.
Which flavor did you eat?
It is a kiwi.
Just eat.
That's
the same
gross.
time.
No, that's awful.
No, that's, yeah.
I don't
You
like
don't
mixed
want the
fruit.
medley of tropical fruit. That's
Keep
just
them
no.
up so they melt. Then pour them
No,
together.
that's what just happened, so.
All right, how do I find slope?
Okay.
Take the derivative. So y prime is equal to, what's the derivative of secant?
Oh. Secant
Cosine.
times tangent.
Yes, secant of x, tangent of x.
Yeah.
And we evaluate at pi over 4. So the secant of pi over 4 times the tangent of pi over 4. What is the secant of pi over 4?
Secant takes place on the right side. Right.
Secant goes all the way around.
Oh.
You're thinking inverse.
Yeah. I'm gonna go with
Well, what does secant go with?
the cosine.
Cosine.
Okay, and what is cosine at pi over 4?
Cosine over 2/2.
Yes.
So then secant would be what in relation to that?
So secant would be
over
2
root. It'd be, yeah.
Yep, which once you cancel everything out is just going to be the square root of 2. So this is square root of 2, and what is the tangent of pi over 4?
Oh,
1.
yeah.
So that's just going to be square root of 2. So this is my slope of the tangent.
Do we have to find a normal?
We will, but I'm going to write the equation of a tangent line first.
Oh, sure.
So my tangent line is going to be at, we also need to find the y value, right? We have x, we need y. Forgot about that minor little detail. So y equals secant of pi over 4, which we just said is the square root of 2. So the ordered pair would be pi over 4 square root of 2 that we're using. So y minus the square root of 2 is equal to square root of 2 times x minus pi over 4. Now, the book doesn't leave it this way. They actually go through and write it in slope-intercept form, but I think I would just leave it here personally because, I mean, or if you want to get everything on one side, you could add the square root of 2 over to the other side, but I would just leave it otherwise. There's really no reason to keep going with it because they give the answer in decimals, and I wouldn't do that. I would just leave it in this form. So then what would my slope of the normal be? If the tangent is square root of 2. Negative root 2 over 2. So then my normal line would be y minus the square root of 2 is equal to negative root 2 over 2 times x minus pi over 4. And again, I would just leave it there. unless it specifies. Let's see, 26 says, assuming the derivative of sine of x is equal to cosine of x, and the derivative of cosine of x is equal to minus sine of x, prove the following. So A is that the derivative of the cotangent of x is equal to minus cosecant squared of x. So basically I'm doing this so that if you happen to only remember sine and cosine, you will know how to find the others. Okay.
Oh.
So I'm going to take the derivative of cotangent, but I'm not just going to say it's minus cosecant squared of x. I'm going to show you why. So cotangent goes with what? What trig function? Tangent. And okay, another way I can write that is what?
Y over x.
Cosine over
In terms of other trig functions, I should specify.
cosine over sine.
Cosine over sine would be cotangent because tangent is sine over cosine. So I'm going to treat this then as the derivative of cosine of x over sine of x. And so to take that derivative, what am I going to be using?
Of the quotient.
Quotient rule. So this is going to be the derivative of the top, which is, they said, where's it, minus sine of x. So minus sine of x times the bottom, sine of x, minus the top, cosine of x, times the derivative of the bottom, which is cosine of x, all over the denominator squared, so sine squared of x. So I've got minus sine squared of x minus cosine squared of x over sine squared of x. And what do we know about the top?
Trig.
Yeah, it's a Pythagorean identity specifically that if I take out a negative, sine squared plus cosine squared is 1. So I need to make sure I keep the negative out front because I just took it out to do that. So negative 1 over sine squared of x, which we know to be negative cosecant squared of x. So by using the quotient rule, I was about to say product rule and I knew that wasn't right. By using the quotient rule, we just proved that the derivative of cotangent of x is negative cosecant squared of x. So should you forget it, that's how you would derive it, basically.
I mean, yeah, I would rather just memorize it.
Yeah, honestly, I
If
would
it comes
too,
to it.
but I will just tell you that like there were several times that I would get to a test or a quiz and I would be like,
You forget.
I feel like I wrote this wrong, I don't feel like this is right or
It's
whatever.
an
And
easy
so
way to check it.
yeah, it's an easy way to check and make sure you did it right if you're not sure.
That's true.
What I do a lot is I will, if I ask you to write the derivative of all 6 trig functions, because that can be a question on your like quiz or test, is I will have you bring them up and let me check them for you, so that way you don't do other problems, you know, with them being wrong. But it's usually not extra credit, it's usually an actual question. So if you're like, I don't know if I did this right or I don't know if I remembered this correctly, and especially when it gets to like the negative signs, that's where I would get confused. I would just go through and derive them to, you know, or a little Miss Independent that wouldn't want to look them up and make sure I did them right. I would just derive them instead. Because, you know, for some reason that seemed like a better option to me. All right, another one, d dx of cosecant of x is equal to minus cosecant of x cotangent of x. So we relate cosecant as what?
1 over sine squared.
Yep. Or not sine squared.
Oh,
Just sine.
that.
So 1 over sine x is how I'm going to do this. So I'm going to take the derivative of this. And so basically I'm dealing with a quotient rule here. Now, the part that's the derivative of the top, obviously, is just 0. So just for the moment, I'm going to put 0 in as a placeholder, but you don't really need to have the 0. Times the top, or sorry, minus the top times the derivative of the bottom. The derivative of the bottom is what? Yep. So cosine of x over the bottom squared, so sine squared. And so by just looking, we don't know what negative cosine over sine squared is, but I can split it up. So I can do basically 1 over sine of x times negative cosine x over sine x, which is now something I do know how to rewrite them. So 1 over sine of x is cosecant of x, and negative cosine over sine is negative cotangent. So the negative actually comes from the cotangent portion. Well, I mean, you gotta put the negative on the 1 over sine of x technically, but then that makes the whole thing negative out front.
Wait, what did you just do?
Basically, I don't know, like cosine over sine squared isn't anything special. So I split it to 1 over sine times negative cosine over sine. And then that way, those are things that I do know, and so you can rewrite them that way. Basically. So again, like, I'm not super inclined to ask you to do this on a quiz or a test, but you probably will have one in your homework that, yeah, I think the one in your homework asks you to do tangent and secant, basically just to show how to do the other two
It's
and
just
to
good-
prove
good
that
to
it's
know.
right. But
It's good
yeah.
to know how to do it.
yeah, because I mean, let's say you get to, you know, the AP exam and you're like, we've learned so much this year, I don't remember what the derivative of cosecant is. You can quickly run through how to find it by just remembering sine and cosine. So, all right, the last thing we've got says this is a group activity, because part of the AP curriculum says that we're supposed to do group projects, so we're going to do a group activity. That's what we're going to do. I promise it won't take long. I basically was like, yeah, we do group activities all the time. It's called class participation. But anyways.
Seriously.
Yeah, we do examples.
But 34, it says in exercises 33 and 34, a body is moving in simple harmonic motion with position s equals f of t, s in meters, t in seconds. And it asks for, we're only going to do part A and B, but find the body's velocity, speed, acceleration, and jerk at time t, and then find it. Part B is to find it at a specific time.
Forgot about the jerk.
It's the
You said problem 34.
Yeah. The instructions are on the bottom of page 146, but the problem is at the top of 147.
Ew.
That's
Yeah.
annoying.
All right, 34 is s equals the sine of t plus the cosine of t.
I don't want it. No.
I don't like
All right, so I'm going to do part A on this side, and then I'll do part B over here. I'll probably do part A, and then we'll just do part B right after it, since it's just plugging in the value.
Okay.
That's awful. All right. So how do I find velocity given position?
Derivative.
So take the derivative. What is that?
Like cosine
cosine
t.
T.
Let's go with a minus sine t.
Cosine t minus sine of t. And then we're doing velocity at pi over 4. So when t is pi over 4, what is the cosine of pi over 4?
Root 2 over 2.
Root 2 over 2. And then sine of pi over 4.
Root 2 over 2.
So root 2 over 2 minus root 2 over 2. So my velocity is 0.
I love that.
Next it wants speed, which is what? The absolute value of v So we just put what we got in absolute value bars. And that means that speed at pi over 4 is still 0.
I did one absolute value bar and then I did a parentheses.
I actually do that a lot.
That makes me so sad.
What did you do?
I did an absolute value bar, but then I did a parentheses to close it.
Alright, then how do I get acceleration from velocity?
Another derivative.
So the derivative of velocity is... Sorry, don't tell me acceleration. I mean, like, what is the derivative of that specific problem?
Are we looking at the
This
absolute
one.
value? Okay.
Yeah.
That's just speed.
Negative sine t
Negative sine of t
minus cosine.
minus cosine of t. So the I was about to say the absolute value. So a of pi over 4. So sine of pi, or negative sine of pi over 4 is...
Negative just root 2 over q.
Negative sign.
And then negative cosine of pi over 4 is...
Negative root 2 q.
So then this ends up becoming negative 2 root 2 over 2, also known as negative root 2.
Too many twos.
And finally, at least they give you pi over 4 and not like pi over 3 or pi over 6.
I know.
Exactly.
Jerk.
Okay, so negative cosine t
They sound like Stitch.
I was just about to say that.
plus sine t.
Negative cosine of t plus sine of t, so jerk at pi over 4. Negative cosine of pi over 4.
Negative root 2 over 2.
And sine of pi over 4.
Plus root 2 over 2.
So jerk is
0.
0.
That's nice.
Yeah, that was nice. Not too bad.
Good with all that?
Yeah.
Sweet.
It's a pretty easy section.
Alright, then your problems are... I already gave you some the other day, right?
Did.
Yes.
Can I
Yes.
write this down real quick?
Sure.
I wrote them down and I don't remember.
I know I took a picture, but it didn't read it. That's actually 1 3.5.
We're on chapter 5, actually. It's 5.3.
Really?
Yeah.
Hey,
Did I know that?
It's the dyslexic version. Alright, so then your problems added today are 21, 25, 29, and 33. I would say you don't, like, this one isn't necessarily included, but make sure you know how to do the second derivative of, like, a product rule of trig functions, which is what 36 is. Just because, you know. Anyways, that's the only one that's like it in the section, that's why. But just make sure you know how to do that. And the answer will be a fraction, just so you know.
what did I do wrong?
That's worse.
And if you don't like, because it has like thetas instead of x's, feel free to change them to x's, because thetas get a little confusing.
Yeah.
Like with these, like make sure you keep t's with these problems, but otherwise I'm fine with you switching them for x's. You good back there?
I did nothing wrong,
I just don't
Nathan.
understand how, like, you think that's good, but, like, no pineapple on pizza.